Let's say you want to hook up 3 I/O pins and 3 push-button switches. This is kind of a typical way you might go about doing it. I've assigned Arduino pins 2, 3, and 4 as the input pins, and I've set each one to pin mode according to the pin number into input pull-up. This means that inside the Arduino there's about a 50 k ohm resistor that's pulling towards the positive side. So if it reads the input, normally it's going to read a 1. However, if you press the button and read the input, you're going to read a 0. So here I have 3 push buttons. They're all connected to ground. So I push each one in turn, and I'm going to get a 0, a 0, a 0 coming on the input here. That's kind of the typical way of doing it. And that's the way I've done it in a previous library that I wrote for the Arduino that I called KeyPlexLib 2. I have a link to that in the notes below. However, it turns out there's another technique for hooking up buttons that I stumbled upon a while back. It's based on a technique that's called Wayneplexing when used for LEDs. It may have been used for switches before, but I haven't been able to find much information on it. So I decided to do this video and write the article showing my method of doing the same thing. Turns out there are other places you can connect switches, and if you know a special trick, you can actually easily scan those switches and get an additional number of inputs. So if I connect a switch, for example, push button switch I should say, I connect one there, I connect one there, and I bring this out over here, and I also connect one there. Now I've added 3 additional push buttons. How am I supposed to read those? Well, the trick is that if you juggle the mode of the pins, you can actually set a given pin to be an output if you do it carefully enough and only make sure that the pin is only ever set to output a 0. So for example, if I take pin 2 low, assuming that none of these other switches are being pressed at the moment, if I take pin 2 low, then when I press this switch here, it'll bring line 3 low, and I can read that as the input. If I bring line 3 low, then when I press this switch, it's going to be able to read it on this pin up here. And likewise, if I take this pin low, I can also read when I press this switch over here. So that's what my new library, which I've labeled KeyPlexLib. I'm calling this technique rather shamelessly Wayneplexing, so to appease my ego and such. But if someone knows another name for it, please let me know. I'm not really calling the name of the library that, but I think what I've done here is fairly unique. So now I'm going to show you how the library that I wrote works, and we'll go into more detail about how you can actually use that and how there are other combinations of these you can figure out that will let you add an increasingly larger number of push buttons to the input. Here's a link to my webpage where I talk about KeyPlexLib, or Wayneplexing on Arduino made easy. At the top of the page, there's a link to my previous article when I first described Wayneplexing and decided to name it Wayneplexing, and a recent article I wrote on a library called KeyPlexLib 2, which is a more conventional library that only handles, for example, 1 push button per input pin, but handles things like in-key rollover or chording. That is, where you can press 1 key and then a 2nd key and then release the 1st key and not lose events, or in chording where you can press 1, 2, and 3 buttons at one time and it'll independently pick up those events. One of the limitations of using Wayneplexing, which is shown in this diagram here, is that if you hook up all these different combinations, you can't really reliably have either rollover or chording. So if you select to use Wayneplexing on a set of input lines and / buttons, it puts the library KeyPlexLib into a special mode where it expects you to press and release only 1 button at a time. So if you press a button, it locks out into the other buttons. So here's a quick example of how you actually implement this. You just simply have to include KeyPlexLib. You declare an object, which in this case I've named buttons, that's of type KeyPlexLib. And the first parameter is going to be the number of I/O pins that you're using, followed by the particular I/O pins that you are using, in this case 2, 3, and 4, because I'm avoiding the use of the TX and RX lines on 0 and 1. Then if you want to use Wayneplexing, you call the method scanPlexKeys, and you pass it true, and that switches into the mode where you can only press 1 key at a time. If you don't call this method, it's only going to scan the keys that are connected to the ground, and it will support all the other mechanisms. So there may be some cases where you want to turn that on and off, but normally you're going to declare the object
and in setup you're going to set it to be true and leave it at that. Then the way it works is every time you call on the object buttons, for example, key available, it initiates a keyboard scan. So that's why it's put in the loop method. You need to call this method repeatedly so that it can detect button presses and releases. If it does get a button press or a button event, it's going to return back true, in which case you can call the method getKeyIndex, and that'll return a value from 0 to n minus 1, where n is the number of push buttons that you've connected. In this case, I have, for example, 0 through 5, so I have six push buttons. Now here's an example of using Wayneplexing with a larger number of input lines. In this case, I'm using 4 I/O lines, 2 through 5, and this enables me to hook up to 10 different buttons. If you want to calculate the number of buttons you can get for a given number of I/O pins, you can use this formula, or you can use this table here. For example, if I use 7 pins, then I can actually scan up to 28 push buttons. That's actually enough to implement a QWERTY style keyboard A through Z and still have enough left over for spacebar and return. Although, because of the limitation of the press and release limitation, I really don't expect anybody. I don't think it would really be practical to use it for an alphanumeric keyboard. Now, as far as the numbering of the keys goes, the index number, there's a simple little technique you can use. If you lay out a little diagram like this, this actually shows the scan codes, the index values you get back when using 4 I/O lines connected to 2 through 5. So you label this column here, starting at the bottom and going up, with the first I/O pin you declared, second, third, and fourth. Then in this row you specify ground, then pin 2, pin 3, and pin 4, but you omit the last pin on the row down here. Then you label 0, 1, 2, 3, and then you skip a space, 4, 5, 6, skip 2 spaces, 7, 8, 9, skip 3, 9. This actually will correspond to the index number you get. For example, if I press the switch that connects pin 2 and pin 3, I'm going to return back the index value of 4. Or if I press the push button that connects pins 3 and 4, I'm going to get the index value back of 7. So here's some additional examples down here showing the same kind of sequencing for the different number of I/O pins that you can use. Now, if you're using different I/O pins, like you're not using 2 through 6, for example, you have to relabel these accordingly, according to the way that you declared them back up here in the constructor. This is the first, second, and third. So this is the first, second, and third, and so forth thing you have to lay out. Now, I want to make a point that a lot of people are familiar with a technique that's often called multiplexing, where you connect a keyboard similar like this, where you're scanning by row and column. That's a similar technique to what I'm describing here, or what I'm calling Wayneplexing, but it really, wastes a lot of potential. With these particular 8, let's see, 1, 2, 3, 4, 5, 6, with these 7 pins here, you could get, as I'm saying, 28 different push buttons instead of the 12 keys you may manage to get here. From a practical standpoint, this may not be something that you need to use if you have a lot of I/O pins available, but if you're using smaller microcontrollers like the ATtiny85, or I like to use the ATtiny10, then it really comes in handy because you don't have that many pins to work with in the beginning. For example, this is a circuit board here that I laid out that has 6 push buttons. It connects to an ATtiny10 using just 3 of the pins, and it actually only has 4 I/O pins. And the leftover I/O pin actually spits out an ASCII serial stream at 9600 baud, so when you press the buttons you get the corresponding ASCII code spit out. I made this as a test fixture for sort of quickly injecting test codes into another system that I was trying to test. Okay, let's quickly go over the API. First, as a constructor for KeyPlexLib, you have to give it some kind of a name when you declare it, and then the parameters are, the first parameter specifies the number of I/O pins, followed by the particular I/O pins you're using, 2, 3, 4, A0, A1, and so forth. Then there's the method key available, which again returns true if there's currently a key available. If that's true, you can call getKeyIndex and get back the actual index value of that. There's getKeyPin, which is a holdover from KeyPlexLib2, which I'm not going to go into here. Then there's also this method called scanPlexKeys. This is what switches the object, for example, buttons in this case, you declared into the Wayneplexing mode. By default, it's going to be switched off. So if you want to use Wayneplexing, you have to remember usually in your setup method to call scanPlexKeys and pass true. There's also a convenience function that's called get pin count that's used in some code that's in the example code that shows you how to enumerate the keys back after you've declared them. Then lastly, there's a method called setCallback, to which you can pass a function that points to a method that needs to be called whenever there's a key press, either key press or release. It takes a key value, which is the index value, followed by a Boolean that tells you whether that key was pressed and or released. But it's best to go look at the callback demo, which is the code in the library. It'll show you how to use this function a lot more clearly than I can demonstrate here. Okay, let's take a look at the example here of how all this stuff comes together and produces a usable result. Here's a breadboard I put together that shows the same configuration I showed in the diagram before. I'm going to talk about the library. It has 6 push buttons hooked up to 3 I/O pins. It also has a joystick down here using an additional, in this case, 5 I/O pins, one for each of the directions plus the select button when you press down. So I'm going to go ahead and run the code here. It says it's ready. So notice now that when I press the first button, I get press key 0, press key 1, press key 2, press key 3, press key 4, press key 5. If I try to hold down key 5 and press any other button, nothing happens. I have to release that button to press another button down here. Now the joystick is hooked up to a second instance. If you notice in the code over here, it's declared as a joystick KeyLib object, which has its own set of I/O pins, and it's not been switched into Wayneplexing mode. So if I go down here and I press up and left and right and down, this is rotated 90 degrees, or select, I get a separate set of buttons from that. If I hold down one of these buttons here, I'm still able to operate the joystick just fine. So that's why I've segregated these buttons into 2 separate sets. So that's a useful technique you can use as well. In addition, I've got another program over here that's designed to use the callback function. So I have a button callback and a joystick callback method. I can't quite fit it on the screen here, sorry. But I'm going to go ahead and I'm going to run this code. I'm going to run this code as well, upload it. And this will give you an example of another way you can use KeyLib. KeyPlexLib, excuse me. So start it up. Now when I press the first button, it says press 0, but when I release it, it says released key 0. Likewise, press release, press release, press release, press release, press release. There are situations in which you may want to, for example, use a keyboard like this. You want to have some operation that continues to take place while you hold the key down and it stops when you release it. So this is an alternate way of using KeyPlexLib. Now the joystick is set to operate the same in this case, but it's also being called via this callback method that it's a pseudo interrupt like method. So here's the callback demo. You can see the entire code here. I've declared the 2 objects above here, the 2 KeyPlexLib objects, buttons and joysticks. I've also called scanPlexKeys on the buttons object, but notice that I've called setCallback on the buttons object, and I've passed a reference to button callback, which is this method right down here, which takes a key value, which is the index value for the key, and also a Boolean value that tells whether the key is pressed or not. Likewise, the joystick, I call setCallback on it as well, and it's going to be separately called whenever there's an event on the joystick, and it just only reports events, in this case when the key is pressed. So you don't see those being printed out. And then the way it works is you only need to call key available for the objects. I'm calling it on buttons and joystick. You still need to call this periodically. It's not a true interrupt because actually the callback happens while you're calling key available. But it's a more convenient way to structure your code if you're doing other stuff inside the loop. You can kind of assume that the handling of the key is the key press is going to take place when it calls the callback method, and the rest of your code can just continue looping and doing what it does.